Okay, so here's Pythagorean theorem. This is a review from 8th grade. You should already have seen this before. Usually you hear a squared plus b squared equals c squared. I'm going to teach you a different way of memorizing it, and instead of a, b, and c being arbitrary letters, we're going to actually tie them down to the right triangle. You can only use a Pythagorean theorem in a right triangle. So here is a right triangle. I know it's a right triangle because of this little ditty right here. In the side, it has a right angle. So these are both legs. They are the two short parts of the right triangle. This other guy over here is called the hypotenuse. So I'm going to label him hypotenuse. I know he's the hypotenuse because he's across from the right angle. So the Pythagorean theorem, in real, true honesty, is not A, B's, and C's. It is legs. So the leg squared plus the leg squared is equal to the hypotenuse squared. That is the actual Pythagorean theorem. A, B, and C are arbitrary letters. They don't mean anything at all. So we could do a quick example. If I had A, B, and C, or leg, leg, and leg, I could say that this is 4 and this is 3 and this is, how do I know what that number is? So I would go leg squared plus leg squared is equal to question mark squared. That's 9 plus 16 is equal to question mark squared. So that would be 25 is equal to question mark. So my question mark would be equal to 5 because I would take the square root. That should be old news. That should not be new. So one thing that might be new, however, is our triples. If you look in the Enjoyment and Challenge book on page 398, it lists for you a set of triples. Triples are a set of 3 numbers that always make a right triangle. 3, 4, 5 is one of our regulars. 3, 4, and 5. 3 and 4 are my legs, and 5 is my hypotenuse. The longest side is always the hypotenuse. So if I did 3 squared plus 4 squared, it would equal 5 squared and be a right angle. Any multiple of 3, 4, and 5 is also correct. So I could say maybe 6, 8, and 10. So why do I have to know this? Well, you don't, but it's going to save you time. And when you take the ACT, you have 60 questions, 60 minutes, and you want to save all the time in the world that you possibly can. I could also half all of those. So maybe instead of 3, 4, and 5, I've got 1.5, 2, and 2.5. That works as well. So there are a list of triples. The common ones that I know are 3, 4, and 5, and those multiples, 5, 12, and 13, and those multiples, and 7, 24, and 25, and again, those multiples, and the last one, 8, 15, and 17. Now, there are more than just those 4 triples. There are infinitely many families, but those are the ones that we use and see the most often. So familiarizing yourself with those will help make your work a little bit quicker. Okay, so this is the theorem you're going to need more than likely on an ACT. They're going to ask you what kind of a triangle that you're looking at just by looking at the lengths of the sides. So if we say that A and B are the short sides of the triangle and C is the longest side of the triangle, we have 3 possibilities. We can say that A squared plus B squared is equal to C squared. If that happens, then our triangle is a right triangle, which we already know because we've been talking about Pythagorean theorem. Now, if our triangles A squared, short side, plus B squared, short side, is greater than C squared, then my triangle is acute. So the way I think about that is that the C is smaller. The C squared is smaller than the other 2, and acute angles are small triangles. The last one would be if it was bigger. So if A squared plus B squared is smaller than C squared, meaning that the C squared is longer, that would be an obtuse triangle. So you'll be given sets of numbers and be asked to determine whether or not it's obtuse, acute, or right. So you might see a triangle problem like this. What kind of triangle is a triangle with sides 5, 8, and 9? So I identify first my 2 small sides, 5 and 8, and then I plug it in. So then I'm going to say 5 squared plus 8 squared. How is that related to 9 squared? So So if I plug that in my calculator, 5 squared plus 8 squared is 25 plus 64. That gives me 89 on this side. And we all know 9 squared is 81. So since 81 is smaller, my c squared is smaller, this triangle is acute. He's a tiny little triangle.